Hello everyone, my name is Amrit Gautam and I'm a student of Helsinki Metropolitan University of Applied Sciences. Today I'm going to present you all about my bachelor's thesis, which is about immutable storage of electric vehicles, charging vehicles using blockchain technology. In this presentation, I'm going to talk about the following contents. First is about thesis objective. Second, the theoretical background, which relates to the blockchain technology, and which is followed by the implementation of the blockchain used in the used in this project. Then I will conclude my presentation with the reference to the future works and the references. The objective of my thesis was to build an immutable storage of records of electric vehicles using blockchain technology. This proof of concept is developed for a startup company called Lincoln in Virta OI, which operates global charging network for electric vehicles. Now I'm going to discuss about the theoretical background which is used while developing this thesis, which is basically about the blockchain technology. So what is blockchain technology? Blockchain technology is an immutable, decentralized, and distributed ledger on which transactions are recorded in chains of blocks. Every peer in the network, of the blockchain network, maintains their own copy of the ledger. Blockchain is developed as a byproduct of a first cryptocurrency called Bitcoin, which was developed by Satoshi Nakamoto. A blockchain is made up of multiple blocks, which consists of block header, multiple transactions, and metadata. The transactions are recorded in a block, and there might be many transactions in one block. The blocks are linked together by cryptographic hash, upon reaching consensus by participating peers in the network. Blockchains can be classified into mainly two types. They are permissionless blockchain and permission blockchain. So what is permissionless blockchain? In permissionless blockchain, any participant can join and leave the network. There is no central authority involved. Example of public permissionless blockchain includes Bitcoin, Ethereum, Webs, and many more. Another type of blockchain is private permissioned blockchain. In private blockchain, it is centralized and regulated by an authority or a consortium of authorities. Only with the correct certificates and permissions, and participants can join and interact with the network. Examples of the private blockchain includes multi-chain, Hyperledger Fabric, BigChain, DV, and many more. In blockchain network, all the nodes are distributed across different places. So it is very important for them to sync up the data that is supplied in the blockchain network. So they need to agree on the single truth of the data when it is being requested to be stored in the blockchain network. How they will be able to achieve the consensus among all the peers of the network when the data is supplied to the network. It is done through the consensus mechanism. All the nodes in the network, they need to agree on a single truth. This is done through the consensus mechanism on which all the peers of the network agree on a single state of the truth. A consensus mechanism is a way to achieve a consensus on a proposed state even in the presence of adversaries nodes and keep the ledger synchronized, following a set of rules by the participating nodes. It is considered as a soul of any blockchain network. Achieving consensus on a single version of a truth by the majority of the peers in the blockchain network is extremely important, and it keeps the network running. Different blockchain platforms implement different kind of consensus mechanism. Consensus mechanism can broadly be classified into the following categories. 1. Computation power, proof of work. In proof of work consensus mechanism, to add a new block to the chain, the miners must compete to solve a complex mathematical puzzle, which is costly and time consuming. The first miner to solve the puzzle will be rewarded with some type of currency for the work done. The next category of the consensus mechanism is system stake, proof of stake, or delegated proof of stake. In this consensus mechanism, a stake put by the user is evaluated when creating a new block. The person who has the highest stake is selected by an algorithm to create as a creator of a new block. There is no reward for creating the new block, but the block creator gets the transaction fee. There is no competition between the creators when creating a block, as it was when the proof of work algorithm is used, the miners always need to compete with each other to create a new block. There is always a race to create a new block in proof of work algorithm. The last category of the consensus mechanism is based on inter-network relationships, which is also called practical Byzantine fault tolerance. Byzantine fault tolerance is the ability of a distributed computer network to correctly reach consensus on a single truth despite the presence of the adversaries or the malicious node. This algorithm uses state machine replication to tolerate Byzantine faults. This algorithm functions effectively if one-third of the nodes is not faulty in the total nodes available in the blockchain network. This consensus algorithm is used by Hyperledger Fabric until the version 0.6. Later on, it was replaced by Kafka ordering service, which will be discussed later. Another key element of blockchain is the ability to execute smart contracts. So what is smart contracts? Smart contracts is the agreement between two parties, which is represented in the computer program, which can be executed automatically when all the conditions are made. The main objectives of the smart contract design is to provide verifiability, privity, enforceability, observability. The prototype developed in this thesis is based on Hyperledger Fabric platform. It is used as a platform of choice for the following reasons. It is an open source platform which supports development of private permissioned blockchains, and it is managed and maintained by Linux Foundation, which is an organization that maintains open source projects. In Hyperledger Fabric blockchain platform, no cryptocurrencies are used by default as a part of transactions. Data is synchronized and stored in all the participating nodes. This platform supports modular component-based architectures for consensus mechanism membership provider for membership and data storage. The components that make up a Hyperledger Fabric are as follows: membership service, ordering service, peer ledger. Membership service manages the identity, authentication, and authorization of all the nodes and users interacting the blockchain network. Ordering service receives the executed transactions from the nodes, orders them, and broadcasts them to all the peers in the network. Peer maintain the state of the distributed ledger in the network. Ledger stores the immutable sequential records of the state transactions that happens through the blockchain network. Architecture of the Hyperledger Fabric. All the transactions of a Hyperledger Fabric are processed based on execute, order, validation architecture. Based on this architecture, the nodes in the network are divided into orderers, endorsing peers, committing peers, and clients, which helps to gain the significant performance and scalability of the system. In this figure, you can see the transaction flow in Hyperledger Fabric blockchain network. In Hyperledger Fabric, all the transactions initiated by the client is processed by the SDK, which is sent to the endorsing peers, as you can see in the figure. So endorsing peers validate the transactions, and then it is written back to the SDK, which will inspect all the messages from the endorsing peer, and it will send all the validated messages to the ordering service. Or the ordering service orders the transactions and creates a block. Thereafter, it is broadcasted to all the committing peers in the network. All the validated transactions that has been done before is again validated by the committing peers, and they update the information on their ledger. After successful records of the block by all the peers in the blockchain network, it is notified to the client through the SDK, as you can see in figure 4. Implementation. Now I'm going to discuss about how the blockchain network is created using Hyperledger Fabric to store immutable charge records for Lincoln and Virta. The prototype of the network consists of one member organization, that is Virta, 3 peer nodes, which they themselves maintain their own ledger, one sole order, and an API server. The whole network runs in isolation inside Virta's private network. The architecture of the network is shown in figure 5. When any kind of charging events happen inside Virta's charging network, it is sent to the main server, which is named here as OCCPJ server. This server forwards the request, which contains all the information about the charging records, to the REST API connected to the blockchain platform. Mainly, start and stop charging transactions is being recorded at the moment inside the blockchain network. Charging stations are not directly connected to the blockchain network, but rather through a proxy-like server called OCCPJ. Another helpful tool which is used with Hyperledger Fabric in the development of the smart contracts and the REST API server is Hyperledger Composer. Hyperledger Composer is open source development toolset framework and modeling language to develop chain codes and applications for blockchain platforms like Hyperledger Fabric, Roha, Sawtooth. In this project, it is used for the development of the smart contracts, which is also known as chain codes and API server. In terms of Hyperledger Fabric platform, a smart contract is known as chain code. Although Hyperledger Fabric provides its own sets of APIs for the development of the chain code, Hyperledger Composer is used here because it provides us higher level of abstraction, which helps to model the business network using assets, participants, and transactions related to them quickly. Hyperledger Fabric Composer helps to bundle all these components together in a business network archive.bna file, which is later on deployed to the Fabric runtime environment. The structure of the business network definition is shown in Figure 6. Another helpful tool that is provided by Hyperledger Composer is REST API Server. Hyperledger Composer is able to generate the REST APIs with the help of the deployed business network archive file, which is deployed to the Fabric runtime environment. It helps to generate a REST server which runs as a standalone Node.js process. It is possible to secure API server using HTTPS or Transport Layer Security (TLS). In Figure 7, you can see the list of generated APIs which is available for the client to use. Figure 7 shows the APIs generated using the Composer REST server. There is an API endpoint for core operations, for start charge and stop charge, and a list of APIs to query the blockchain network, and a list of API endpoints through which we can query the network to get the data stored in the ledger. The overall conclusion of my thesis is that blockchain technology allows the storage of immutable data in distributed and trustless environment involving multiple organizations. The possibility to store charging records using blockchain technology helps to gain the trust and transparency of customers, regulators, as well as auditors, which is very helpful for a startup company. While blockchain technology stores the data in an immutable fashion, but it has no control over the integrity of the data that is being sent to it. It doesn't take into the account of outside factors like human interference or sensors malfunction when the data is being generated and sent back to the blockchain network for storage. Permission blockchain technology is still in its early years of development. A lot of studies and research has to be done before it can be fully accepted in the production environment. Future works. While the thesis was being carried out, a new use case of blockchain technology in the field of electric mobility has been discovered. With the help of blockchain technology, there is a possibility to create a single global network of connected chargers where different organizations like Virta and other companies who provide the information about the charger and cost within using the blockchain technology. Financial transactions can be carried out through smart contracts between the organization directly without the need of any trusted third party. In Figure 8, it is shown how the blockchain technology can be used to integrate all the information using a shared ledger between different organizations through which customers from different organizations can charge. Here are the list of references that I have used while making this presentation. Thank you.